we are going to discuss displacement in oscillations. Means the displacement we are how we are going to represent usually, how we are going to find. Normally, if you are taking any oscillatory object, it moves from its mean position to certain extreme position, right? So this part, how it has moved from 0 to some position, that is called as displacement. Okay. If with respect to this here theta is angular displacement, here it is x is the linear displacement we call. Simply a displacement of a oscillating body from its mean position to extreme position is called as displacement. Displacement. Okay. Now this displacement, how I am going to represent in a form of mathematical function, or I am going to express with respect to mathematical function of time. Let us consider a mathematical function of time. Initially, the particle or in whatever the displacement I am talking about in the case of oscillations, from here to here it has moved. Again, it comes back with the same distance. Again, it will go to the extreme position. It comes back. Same thing it happens in the case of a compressed or stretched spring, right? So both are periodic. Means I need to express my function of displacement always in a form of periodic. So I am considering one periodic equation in a cosine form, means cos, that is f of t equal to a cos omega t, where a is considered as a amplitude. Amplitude in the sense from the mean position to extreme position, whatever the maximum displacement is there, that is called as amplitude. Okay, what is the amplitude? Amplitude is a maximum displacement of oscillating body from mean position. Mean position. So f of t equal to a cos omega t I have taken. This f of t equal to a cos omega t is a periodic function that we know clearly. Here omega t is, if it is increased, it will be increased by 2 pi radians, means the angle will increase 2 pi radians. Here omega is the angular velocity, t is a time. Okay. Now if I wanted to increase further, means if there is a change in the position of the particle, initially time t, then later on the particle is somewhere, then some amount of time it has taken from moving from one position to another position. So time will be added, the time period will be increases. So usually whatever the time period is changes, the function of time t equal to a cos omega t also will be changes. Time period in the sense t equal to 2 pi by omega we will write from basic time period definition. Okay. So this t, how I am going to represent with respect to this equation. If the time period has increased or changed, a cos omega t I said. Here whatever I am writing, omega t plus capital T I am writing. Means initial position at cos omega t, the change position by that time with respect to time is also changed, no? So cos omega of t plus t, the function of time periodic equation has changed. So the function f of t is periodic with capital T, we can say. This is with the small t. The periodic, the function of time periodically, f of t equal to a cos omega t, which we considered initially. Because of time period changed for a time period t, my equation has changed, periodic equation has changed, f of t equal to a cos omega of t plus capital T. This is thus the function of f of t is a periodic with period t. Now to have a linear combination, what is a linear combination? Here I have represented in terms of cos omega t. This equation not need to necessary to put in only cos omega t. Periodic function can be sin omega t also. You can also use f of t equal to a sin omega t. Of course, this depends on the angular displacement comes, but both are periodic waves only. I can use combinedly also, that we call as linear combination of function of time f of t equal to a cos omega t plus a sin omega t. This gives a combination of cosine as well as sine. This I can represent both are same, no? Okay, wait a minute. This is, I'm writing a cos sin omega t, this is b cos omega t. So amplitudes are different for the different waves. So a sin omega t plus b cos omega t I am writing. This gives a linear combination. This gives a linear combination. This is also a periodic function with the same time period capital T.